Next up in the series of videos on factoring is going to be factoring quadratic trinomials, where the coefficient on the squared term or the coefficient on the lead term is 1. Okay, so it's going to feel a little different than the factoring we've done so far. So it's not quite like factoring out of GCF. It's not quite like factoring by grouping. Okay, it's kind of its own thing, but this comes up a lot, and this is something that if you know how to do this kind of factoring and you know how to do it well, it's going to save you a lot of time in the future. Okay, now, like with the previous video, anytime you're factoring, the first thing you do want to look for is a GCF, but once you factor out the GCF, you're not necessarily done. So let's take a look. So first thing we need to look at is what is a quadratic trinomial, okay? So a quadratic trinomial, let me go to black. A quadratic trinomial is any trinomial of the form ax squared plus bx plus c, where a, b, and c are real numbers. Wow, that got messy. Are real numbers such that a is not 0. Okay, so a quadratic trinomial is any trinomial of the form ax squared plus bx plus c. A, b, and c are real numbers. That means they can be decimals, they can be fractions, they can be integers, whole numbers, whatever. The only condition is that a cannot equal 0. What makes this a quadratic trinomial is the fact that you have this second degree term, okay? So these are all second degree polynomials. Okay, so these are second degree. We'll call them trinomials since we're specifically talking about trinomials. So that means you have to have this x squared term. So if a becomes 0, then the x squared term goes away, and then you would be left with just bx plus c, which is simply a linear expression. Okay, so we want this to be quadratic. Quadratic has to be second degree. That means you have to have that x squared term. Okay. So for us, we're going to look at factoring where the coefficient on the squared term a is very specifically 1. Now, I do want to point out a few things. You have a's, that is always the coefficient of the squared term. You have b, which is always the coefficient of the linear term. And you have c, which is always the constant. And as we move through this, talking about quadratic trinomials in this video, and then again in the next video, you're going to see me talk a lot about a, b, and c. Okay, a, b, and c are very specific things. A, again, is the coefficient of the squared term. B is the coefficient of the linear term, or just the x. And then c is always the constant. Okay. So let's talk about kind of what this is going to mean to us. Now, first thing I want you to know is this will undo the FOIL method. So back when you were learning about multiplying polynomials, one of the things we did was multiply two binomials. And when you multiply two binomials, the process behind that is FOIL. This will undo FOIL. This means results will be the product of two binomials. Okay, so keep that in mind. We're undoing the FOIL method, so our product or our answer is going to be the product of two binomials. So let's consider x plus 2, x plus 3. Now, back when we were just dealing with polynomials, we would have learned FOIL. So remember, FOIL stands for first, outer, inner, last. So first terms, outer terms, inner terms, last terms. And that just gives you an order to multiply these terms out in. So what we would do is we would take, okay, x times x is x squared. X times 3 is 3x. 2 times x is 2x. And 2 times 3 is 6. And then after that, you would simplify. So we would have x squared plus 5x plus 6. Now, let's look at this 6 right here. And then let's look at 2 times 3. Well, 2 times 3 is 6, all right? And then let's look at this 5 here. Well, if I take 2 plus 3, I get 5. So basically, our goal in factoring here is to find factors of C, remember, C from over here. So factors of C, that just means the constant in your quadratic trinomial. We're going to find factors of C that have a sum means add, of B. And remember, B is the coefficient of the square term. So as long as A is 1, this is easy, okay? So as long as A equals 1, and remember, A is the coefficient of the square term. So as long as A is 1, this is easy, okay? So again, we're looking for factors of the constant that add to be the coefficient of the linear term, and this is pretty straightforward. It's easy. That's all we have to do as long as A equals 1, okay? So I say we look at some signs and how that's going to play out, and then we move into just looking at examples. So what about signs? All right. So basically, you're looking for factors of C. So two numbers that would multiply to give you C, but would add up to give you the coefficient of the linear term, okay? So what if we had, I'm going to go ahead and just put x squared, because remember, everything in this video, we're assuming A is 1. So let's say we have x squared plus bx plus C. So notice here, C is positive. Now, how do I multiply numbers and get a positive? There are two ways that we can do this. You can multiply two positives and get a positive product, or you can multiply two negatives and get a positive product. So, factors of C are either both positive or both negative. Okay, so if B is positive, so are the factors of C. If B is negative, so are the factors of C. So in this particular example right here, we would want two positive factors of C, okay? Now let's consider x squared minus bx plus c. Same thing, c is positive, so that means the factors of c are either both positive or both negative, but in this case, b is negative. So that means we need two negative factors of c. So again, just to kind of recap this idea, signs are going to be a big deal in this video. And so as we move through, hopefully it'll kind of become a little bit more second nature. But basically, if the C, the constant in your quadratic trinomial, is positive, both factors that you're looking for are going to be either both positive or both negative. And B tells you what. So if B is positive and C is positive, you need two factors of C that are positive. If B is negative, that tells you the two factors of C have to be negative. So now let's look at what if C is negative. Well, if C is negative, the factors of C must have different signs. Remember, factors are numbers that are being multiplied, so we're looking for factors of C. We're looking for two numbers that would multiply to give us C, and if C is negative, one of those factors has to be positive, one of those factors has to be negative. So if I had x squared plus bx minus C, the larger factor of C will be positive. So I find my factors of C and I've got to figure out, well, which one's positive, which one's negative. B tells you if B is positive, that means you need a positive sum. So the larger of the two factors would have to be your positive. Now, if I had x squared minus bx minus C, the larger factor of C will be negative. So again, if I have a negative C, my factors have to have opposite signs no matter what. But you have to determine, well, which one's positive, which one's negative. B always tells you if B is negative, that means the sum has to be negative. And the way that would occur is if your larger factor is negative. Okay, so this is kind of a lot to take in on this slide. Signs. It all comes down to starting out with what is C? Is C positive or is C negative? Okay, if C is positive, the two factors of C that you're looking for have to both be positive or they both are negative. And B tells you which. If B is positive, you're looking for two positive factors of C. If B is negative, you're looking for two negative factors of C. Now, on the flip side, what happens if C is negative? Well, factors, remember, are being multiplied. And the only way to multiply two numbers and get a negative is if one of those numbers is positive and the other one is negative. So which sign is going to go to the larger factor? Which sign is going to go to the smaller factor? Well, this all comes down again to B. If B is positive and C is negative, the larger of the two factors will be positive. If B and C are both negative, the larger factor will be negative. Okay, so really study this. Make sure you understand this. Sorry, I had to get a sip of water. And hopefully as we go through and look at lots and lots of examples, this will become a little bit more clear. So fair warning, I do have a lot of examples. I think I have, it looks like I have 18 examples. So what we're going to do is we're going to do 8 just basic examples, and then we're going to look at special cases. So like weird, tricky things that could potentially come up with this. Okay. So starting out, we're just going to look at basic, simple examples. Okay. So first up, I have, let me go back to black. Gracious. So first up, I have x squared plus 13x plus 22. Now notice C is positive, okay? So if I go back to this slide right here, C is positive. I know that my two factors of C that I'm looking for are both positive or both negative. B will tell us which, okay? So I'm looking for two signs, two factors that have the same sign, and they have to be positive because I've got positive 13 here. So let's start looking at factors of 22. We're going to look at pairs of numbers that when multiplied would give us 22. Sorry, I've talked a lot today and my throat's a little scratchy. So first up, we know we're dealing with positive factors, so we would have 22 and 1. Well, 22 plus 1 is 23. That doesn't work. Next up, we have 11 and 2. Well, it just so happens 11 and 2 add up to be 13. So that's what we need. So here's how you write this out. As long as the coefficient on the x squared term is positive 1, you basically start with two binomials, both of which start with just an x, okay? Then we go and we look at factors of C that add to B. Whatever those factors are, go down here. It does not matter where you put the plus 11 and where you put the plus 2 as long as you have the signs right. Now, if you want to check these, so we would check by FOIL. I'm going to check this one, and then we're not really going to check anymore for a minute. We might check a few throughout, but just to give you an idea, if you wanted to check this, you would take x plus 11, x plus 2, and then you would just perform FOIL. So we would take the first terms, x times x is x squared. the outer terms, x times 2, the inner terms, x times 11, and the last terms, x times 2. And then we simplify. Whoops. So we get x squared plus 2x plus 11x is 13x, and then plus 22. So that's it. Remember, before we would have started with x plus 11 times x plus 2, and our job would be to get x squared plus 13x plus 22. But now we're undoing that FOIL method, so we're working backwards, all right? So again, when you're factoring these quadratic trinomials, your results will be two binomials, the product of two binomials, okay? So let's look at some more examples. Next up, let's say that we have x squared minus 10x plus 24. Well, C is positive, and remember, if C is positive, you need two signs, or you need two factors that have the same sign, both positive or both negative, and remember, B tells us which. So in this case, B is negative, so that means we want two factors of 24 that are both negative. Oh, shoot. This is actually, please don't get mad. Well, you can get mad if you want. No, this will work. This is good. I was thinking different factors. Okay, so we need two factors of 24 that are both negative, and they both have to be negative so that when we add, we get negative 10. Okay, so we could have negative 24 and negative 1, negative 12 and negative 2. We could have negative 8 and negative 3, or we could have negative 6 and negative 4. So let's see which of these pairs adds up correctly. Well, negative 24 and negative 1 adds up to negative 25. That doesn't work. Negative 12 and negative 2 add up to be negative 14. That doesn't work. Negative 8 and negative 3 is negative 11. It's close, but it still doesn't work. And then finally, we have negative 6 and negative 4, and there you have it. Those are the factors of 24 that add up to be negative 10. So remember, we're looking for numbers that when multiplied, we get 24, but when we add them, we get negative 10. So we start two binomials. Each begins with an x, and then I just fill in those factors. And that's it. So as long as a, the coefficient on the squared term, is 1, this is pretty easy. Okay, so let's try another one. Let's say that this time we have x squared plus 12x plus 35. Let me fix that x, it looks kind of wacky. Okay, coefficient of the squared term is 1. So we look at C. C is positive. That means we need factors with the same sign. And the coefficient of x, or B, tells us what that sign is. Since B and C are positive, we want two positive factors of C that add to give us 12. So we could have 35 and 1. We could have 7 and 5. And I think that's it. So 35 and 1, both positive, but it adds to 36. That won't do. 7 and 5, both positive. If we add them, we get 12. So there you have it. Remember, we're looking for two numbers that multiply to give us the constant and add to give us the coefficient of x. So we're good here. We start two binomials with an x, and then we just fill in those factors. And remember, this process is only valid if the coefficient on the squared term is 1. Okay. Next up, let's say that I have x squared minus 15x plus 44. So coefficient on the squared term is 1. I look to C. C is positive 44, so that means the signs on the two factors I'm looking for are either both positive or both negative, and the coefficient of x tells me positive or negative. Since the coefficient of x, or B, is negative, I want my two factors of 44 to be negative. So I could have negative 44 and negative 1. I could have negative 22 and 2. And if you ever get stuck and you can't figure out your factors, just use a calculator. Take whatever the number is, 44, divide it by 1, divide it by 2, divide it by 3, divide it by 4. Next up, we would get negative 11 and 4. You take 44 divided by 5, 44 divided by 6, 44 divided by 7, 44 divided by 8, and just keep going through this. And then eventually you'll see that you are starting to repeat factors. So anytime you get a decimal, toss it, only look at those whole numbers. And here we have all of the factors of 44, okay? So just pretend we've gone through the calculator and this is it. We start and look at adding them. Well, negative 44, negative 1 doesn't work. It's negative 45. Negative 22 and negative 2 doesn't work. That's negative 24. So then hopefully negative 11 and negative 4, well, negative 11 and negative 4 does add up to be negative 15. So we take two binomials, start them both with an x, and fill in those factors. And that's it. That's it right there. Let me do that as a box so it's consistent. So there's your final answer. Okay, now on the next slide, we're going to look at the same types of examples, but this time C will be negative. Okay, and just remember, if C is negative, we're looking for factors of C that have different signs. Okay, so let's look at x squared plus 7x minus 18. Okay, C here is negative, so we've got C is negative 18. And remind us, what happens when C is negative? Well, if C is negative, you have factors of C that have different signs, so one positive, one negative, and the sign on B tells you the sign of your larger factor. If B is positive, your larger factor has to be the positive one. If B is negative, your larger factor is going to be the negative one. Okay, so in this case, our larger factor is, or the coefficient on B is positive, so that means the larger factor is going to be the positive factor. So we could have 18 and negative 1, we could have 9 and negative 2, or we could have 6 and negative 3. Okay, well, 18 and 1 gives us 18 and negative 1 gives us 17, so that doesn't work. 6 and negative 3 gives us 3, so that doesn't work. 9 and negative 2, however, does add up to 7. So we start two binomials with an x, and then we fill in those factors. Now, it doesn't matter which factor you put the positive 9 and which factor you put the negative 2. It doesn't matter the order, like which binomial gets which. Just make sure the sign in front of the factor is correct. So I could have easily written this x minus 2 times x plus 9. That would be fine. But I want to just, it doesn't matter which binomial gets which factor. Just make sure the sign is correct. Okay. That took me a long time to spit out something pretty simple, but that basically sums up today. Okay, next up we have x squared minus 13x minus 48. Okay, so C is negative. That means the factors of C have to have different signs. So the factors of 48, negative 48, have to be one positive, one negative. And what we do is we look to B. B tells us the sign of the larger of the two factors. So in this case, the larger factor is going to be the negative. Okay, so we would get negative 48 and 1, negative 24 and 2, negative 16 and 3, negative 12 and 4, negative 8 and 6, and I think that's it. So let's see what works here. Well, negative 48 and 1 is negative 47. That doesn't work. Negative 24 and 2 is negative 22, so that doesn't work. Negative 16 and 3, that does equal negative 13, so there you have it. So we start two binomials, each with an x, and then we fill in those factors. Again, it doesn't matter which binomial gets which factor, but the sign in front of the factor does matter, okay? So again, we were looking for two numbers that when we multiply, we get negative 48, but when we add, we get negative 13, and those factors are positive 3, negative 16. So that's your final answer, okay? Let's try two more. So let's say we have x squared plus x minus 30. So C is negative 30. That means we need factors with different signs. And the coefficient on x tells us what? So B, the coefficient of x, the sign on that tells us the sign of the larger factor. So these two factors that we're looking for, different signs, and we want the larger factor to be positive, okay? So we could have 30 and negative 1, 15 and negative 2. We could have Whoa, that's not right. 15 and -3. And then we could have 6 and -5. Okay. Oh, we could, good grief, I did have that wrong. Let's start that over. Do you all ever watch these videos and just laugh at some of the dumb mistakes I make? Okay, so we could have 30 and -1. We could have 15 and -2. We could have 10 and -3, bless my heart. And then finally, we could have 6 and -5. Okay, so 30 minus 1 is 29. That doesn't work. 15 minus 2 is 13. That doesn't work. 10 minus 3 is 7. That doesn't work. 6 minus 5, however, is 1. So that works. We start two binomials, each with an x, and then we fill in those factors. And again, it doesn't matter which binomial gets which factor as long as the sign in front of the factor is correct. So 6 times -5 is -30. 6 plus -5 is 1. So everything checks out. You can also FOIL if you doubt your answer. Okay. Next up, we have x squared minus 2x. Let's see, where am I? Yeah, minus 24. So x squared minus 2x minus 24. So in this case, again, c is negative. So the factors of c that we're looking for need to have different signs. And in this case, since b is negative, we want that larger factor to be the negative, okay? So we could have -24 and +1. We could have -12 and 2, -8 and 3, -6 and 4. All right. Well, -24 plus 1 is -23. -12 plus 2 is -10. -8 plus 3 is -5. Finally, -6 plus 4 is -2. So that's the magic pair. -6 times 4 is -24. -6 times 4 is -24. -6 plus 4 is -2. So I start two binomials, and it does not matter which order I put these factors as long as the sign in front of the factor is correct. So again, -6 times 4 is -24. -6 plus 4 is -2. So quick recap. Quadratic trinomials are of the form ax squared plus bx plus c. A, b, and c are just real numbers. The only condition is a cannot equal 0. What makes a quadratic trinomial quadratic is that degree 2. So you have to have an x squared term. This video is focusing only on quadratic trinomials where a is equal to 1. So this right here, this is what it's all about. All of these quadratic trinomials in this video, the coefficient on the x squared term ends up being 1, okay? So we talked about the signs. You've got to be really careful here. Basically, what we're doing is we're looking for two numbers that multiply to give us c, the constant, but simultaneously add to give us b, the coefficient of x. So if c is positive, those two factors are either both negative or both positive. The coefficient on x tells us which. If c is negative, those factors are going to be one positive, one negative. The coefficient on x tells us which is going to be the larger. So the larger, if b is positive, the larger factor is positive. If b is negative, the larger factor is negative. And then we did lots of examples. Okay. So next up, we're going to talk about special. Whoa, let me go back to black. Next up, we're going to talk about special cases. Okay. So first up, we're just going to look at examples and we'll kind of discuss what's happening as we go. So first up, I have x squared minus 4x plus 13. So I've got a positive c, which means I'm looking for two factors of 13 that are both positive or both negative. And the coefficient on x tells me what that sign is going to be. In this case, they would need to both be negative. Well, the only factors of 13 are -13 and -1. But what happens when we add -13 and -1? Well, we would get -14. But the coefficient on x isn't -14, it's -4. So this is a situation where we cannot factor. We cannot factor because there are no factors of c with a sum of b. we say these trinomials are prime. So if you have something that you cannot factor in this series of videos, so when you're factoring these polynomials, if something is not factorable, we would say it is prime. So this is a prime polynomial. It's perfectly lovely, it just can't be factored. All right, so let's look at another one like that. Let's say we had x squared minus 11x minus 3. All right, so in this case, c is -3, so our factors are either going to be -3 and 1 or 3 and -1. Well, -3 and 1 is -2. 3 and -1 is +2. Neither pair of factors adds to be -11. So again, whoa. So again, we would say that this is prime. So be on the lookout for prime polynomials. Now, here's your warning. Prime polynomials are going to show up every now and again. If you're going through your work and every other problem is prime, you're doing something wrong, okay? So just because you can't factor the polynomial doesn't mean the polynomial is prime. It just might mean that you need to find a different pair of factors that works, like maybe your arithmetic is wrong. But prime polynomials do exist. The next special case, so this is, we'll call the previous slide, we'll say special case number 1. How about that? And now we'll go to special case 2. So special case number 2. So in special case number bless my heart. In special case number 2, you have double variables. And it looks so messy and so scary at first, but it's actually really, really easy. So something like x squared plus 15xy plus 56y squared. Okay, so here's the deal. You've got the x squared, you've got the y squared, and then you have the combination of x and y. Nothing weird happens here except when you start those binomials, as long as the coefficient on x squared is 1, you start the binomials each with an x, and you end each with a y. And in just a second, I'll FOIL this out to prove to you it really does work. Okay, so you start your two binomials with an x, just like we've been doing, but end each binomial with a y, and everything works out. Other than that, everything else is the same. We're going to call this C. We're still going to call this B. Okay, so we still want to find factors of 56, both positive or both negative, that add to positive 15. So this would tell me that I need two positive factors of 56 that would equal 15. So we could have 56 and 1. Well, that obviously doesn't work. And then we could have 28 and 2. And if you're unsure of the factors of 56, just go through your calculator. All right. Oh, here it is. No, almost. So let's see, 56 divided by 6. No, 56 divided by 7. Bingo. All right. So we need factors of 56 that add to 15. Well, 56 and 1 is too big. 28 and 2 is too big. 14 and 8 or 14 and 4 is too big. 8 and 7, however, is just right. So I've used this analogy before, but it's kind of like Goldilocks and the Three Bears. You know how everything was too hard, too soft, just right, or it was too hot, too cold, or just right. And here, it can't be too low, can't be too high. It has to be just right. So now, all we have to do is fill in these two factors. So 8 times 7 is 56. 8 plus 7 is 15. So I add an 8 and I add a 7. Now, let me show you that this really does work. So we check by foiling. So I've got x plus 8y, x plus 7y. I multiply the first terms and I get x squared. I multiply the outer terms and I get plus 7xy. I multiply the inner terms and I get plus 8xy. And then finally I multiply the last terms and I get, whoops, I get 56y squared. Clean it up, x squared plus 15xy plus 56y y squared. So it really does work. If you have this weird double variable thing, start each binomial with an x, end each binomial with a y, or whatever variables you have. I'll show you one with like weird variables so you'll know how to deal with it. And then that's it. Just fill in the factors like always. Okay, so let's say for this one, I have c squared minus 5cd minus 36d squared. So the lead term in this case would be the c squared because c comes first in the alphabet. And since you have two terms that contain a c, you want the term that has the higher exponent on c. It's kind of a long process, but just trust me, c squared is your lead term here. Coefficient on the lead term is 1. So what we're going to do is we're going to look for factors of negative 36 that add to be negative 5. So that means our factors have to have different signs, and the larger of the two factors is going to be negative. So I could have negative 36 and 1, negative 18 and 2, let's see, negative 12 and 3, negative 9 and 4, or negative 6 and 6. Okay, so adding, we get negative 35. That won't work. Negative 16 doesn't work. Negative 9 doesn't work. Negative 5. So ding, 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 there it is. So here's the setup. Two binomials. You start each binomial with whatever that lead term is, whatever that variable is. So in this case, c. So you start each binomial with c. And then that second variable, end each binomial with that. And then fill in those factors. And just to prove it one more time, we've got c minus 9d, c minus 4d, c times c is c squared. C times negative 4d is negative 4cd. Let's see, that's positive right there. So I'll make that positive. Negative 9d times c is negative 9cd. Negative 9d times positive 4d is negative 36d squared, c squared, minus 5cd, minus 36d squared. There you have it, folks. So if you have that weird double variable thing, it's not that big a deal. You just start each binomial with the x, end each binomial with the y. Okay? So special case 3. We have something that's not in standard form. Now, generally speaking, when you have to put something in standard form, it's going to be pretty easy. You're going to have a single variable. And when you have a single variable, standard form is easy. Highest degree to lowest degree, okay? So basically, we could say we had something like negative 7x plus 12 plus x squared. This is all sorts of wrong. The very first thing you want to do is make sure your polynomial is in standard form. So we would put this in standard form. Okay, so that would be x squared first, then negative 7x, then 12, and then factor like normal. All right, so I'm looking for factors of 12. Both would end up being negative because we've got negative 7 here. So I could have negative 12 and negative 1, negative 6, negative 2, negative 4, negative 3. Well, that's negative 13, negative 8. That one's just right. So I would go x minus 4, x minus 3. And that's it. So basically, if you have a polynomial that's not in standard form, put it in standard form and then factor. So same thing over here, negative 10 plus y squared plus 3y. I would rewrite it as y squared plus 3y minus 10. Now I'm looking for factors of negative 10, so different signs, and I want the larger one to be positive. So I get 10, negative 1, 5, negative 2. Well, 10 and negative 1 is too big, but 5 and negative 2 is just right. So I would get y plus 5, y minus 2. And that's it. So for special case number 3, it's actually quite simple. Just put your polynomial in standard form and then factor. Okay. Special case number 5 and special case number 4 and 5 are almost the same, but I do separate them. So special case number 4, A is -1. So far what we've been dealing with is these quadratic trinomials where A is specifically 1, okay? So here A equals 1, and I circled it down here in red. A is 1, okay? So the issue here is that we're saying A is -1, all right? So let's say we had something like -x squared minus 11x minus 18. Remember earlier in the 2 videos we've already done, we said if the lead term was negative, you had to have a GCF that was negative. Well, the issue here is we don't have a GCF, we just have this negative. So what you have to do here is factor out a GCF of -1. All right, so I'm going to go ahead and factor out the -1. You can show this, but as you get more comfortable with factoring, this is something you can definitely do in your head. But -x squared divided by -1 is +x squared. -11x divided by -1 is 11x. And -18 divided by -1 is 18. And then factor like always. So we want factors of 18 that are both positive and that would add to 11. So we could have 18 and 1, we could have 9 and 2, or we could have 6 and 3. Well, of these, the only pair that adds up just right is 9 and 2. So here's what you do. The -1 that you factored out, you have to include that in your final answer. So I usually don't write the -1, I just write the negative. And then I start my 2 binomials, x and x, and then I go +9 + 2. And that's it. And then I would just put here, don't forget the negative that you factored out. Exclamation point. Okay, let's look at another one. So let's say that we had -x squared plus 6x minus 8. Everything looks good except for the fact that the lead term is negative, so I factor out a -1, and all that does is change all of my signs. -x squared becomes +x squared. +6x becomes -6x, and -8 becomes +8. So I factor like normal now. The stuff inside parentheses is good to go. I need factors of 8 that are both negative. So I could have -8 and 1, or -4 and -2. And it just so happens the -4 and the -2, that's the pair that adds up correctly. So I keep the negative, and then I start my 2 binomials with x, and then I throw in a -4 and a -2. So now let's go ahead and just check this one. So we could check by FOIL and distributive property. So I've got -x minus 4, x minus 2. I'm going to FOIL first. So I'm going to keep that negative in the set of parentheses. X times x is x squared. X times -2 is -2x. -4 times x is -6x. -4 times -2 is 8. So then I've got x squared. Oh, I see what I did. I put a 4 here, or a 6 here, but it should be a 4. Xx plus 8. Now at this point, you don't have what you actually started with, but you're close. We've got this -1 times in parentheses x squared minus 6x plus 8. So I distribute, and I get -x squared plus 6x minus 8. And that was what we started with, okay? So this is a little wacky. It doesn't happen too often, but be on the lookout for it. If A is -1, you can't just jump into factoring. Your signs will all be wrong. You have to factor out the negative first and then proceed with your factoring, okay? Last special case, this is special case 5. And here you have a GCF. You already should know that first thing you want to do when you're factoring is look to see if you have a GCF overall. And I've been a little lazy in this video. I knew we didn't have a GCF, so I didn't really harp on it too much. But for these last 2 examples, you will have a GCF. So let's say we have 4x squared minus 8x minus 60. Well, we have a GCF of 4. 4 goes into 8, 4 goes into 60. factor it out. So I get 4 times, well, when I divide these terms by the GCF, 4x squared divided by 4 is just x squared. Negative 8x divided by 4 is negative 2x. And negative 60 divided by 4 is negative 15. And then at this point, factor like normal. But I am going to keep my 4 that I have all along. So inside the parentheses, I have a negative 15. So I need factors of 15 that have different signs. And the negative 2 tells me that the larger factor is negative. So I get negative 15 and 1, negative 5 and 3. Well, negative 5 and 3 is the pair that works. So what I'm going to do is write down that 4, the original GCF. And then I go x minus 5, x plus 3. And that's it. All right. So let's do another one. Let's say that we had negative 5x to the third plus 35x squared minus 60x. We do have a GCF. Okay, so the GCF in this case, a couple things to notice. Your lead term is negative. So our GCF has to be negative. And then I noticed that all of the terms have a 5 and an x in common. So I'm going to factor out the negative 5x. And so if I divide all of these by negative 5x, what do we get? Well, we get positive x squared, negative 7x, and positive 12. Okay, so now I would factor what's inside the parentheses. So I need factors of 12 that are both negative. The reason I know they're both negative is this is negative 7 here. So I would want negative 12 and negative 1, negative 6 and negative 2, or negative 4 and negative 3. Which pair adds up correctly? Well, the pair that's just right is negative 4 and negative 3. So I take my negative 5x and I get x minus 4, x minus 3. Now, if you wanted to check one of these, so let's say we were going to check this answer that we have right here. So I want to check negative 5x times x minus 4, x minus 3. Remember, the goal here was to get negative 5x to the third. Let me remind myself, I forgot. Our goal is to get this right here, negative 5x to the third plus 35x squared minus 60x. Whoops, let me fix that. Oh, man. So remember, this is what we started with right here. So this is kind of our goal. What I would do first is I would FOIL, then I would distribute. So FOIL first, distribute second. I just think it's easier to do it that way, but whatever works for you. So I'm going to keep my negative 5x. And then in parentheses, I'm going to take x times x, x times negative 3, negative 4 times x, and negative 4 times negative 3. I'm going to simplify a little bit. So I get negative 5x times x squared minus 7x plus 12. And then I would distribute. So negative 5x times x squared is negative 5x to the third. Negative 5x times negative 7x is positive 35x squared. And then negative 5x times 12 is going to be negative 60x. And you can see there we got exactly what we started with, okay? So a kind of halfway recap, we're going to look at just the special cases. Special case number 1, you have a prime polynomial. This occurs when there are no factors of C that add to B. And keep in mind, everything in this video, A is 1, okay? So as long as A is 1 and there are no factors of C that add to B or that give you a sum of B, you've got a prime polynomial, okay? Next up, special case 2, you had the double variable situation. So remember, you start each binomial with the first variable, you end each binomial with the second variable, and then everything else is the same. Special case number 3, you have a polynomial that's not in standard form. No big deal, put it in standard form. And standard form is highest degree to lowest degree. Once it's in standard form, factor like always. Special case number 4. What we've dealt with so far is A, the coefficient on the squared term was 1. But in this case, they throw you a curveball. They're like, hey, we're going to make A -1. No big deal. Factor out a GCF of -1, and then factor like always. Just don't forget the -1 in your final answer. And then special case number 5, you have a GCF. So again, they throw you a curveball. A is supposed to be 1, but then all of a sudden they give you these problems where A is not 1. But it just so happens that A is the GCF. So factor out the GCF, factor like always. Just don't forget to leave that GCF in your final answer. Okay? So that's it for factoring quadratic trinomials where the coefficient on the square term is 1. So we looked at just the basic factoring, how to do it. Big thing is signs. Really be comfortable with your multiplication tables and then signs. You've got to know how that works or you're not going to have an easy time with this, okay? So work on that. Work on those multiplication tables and practice the signs, okay? So we looked at just how to do the basic factoring of a quadratic trinomial where A is 1. And then we looked at the special cases. So remember, prime polynomials, okay? Double variables, all right, not in standard form. They throw the curveball where A is -1, and then they have a GCF. So those are those special cases. So the next video is going to be still factoring quadratic trinomials, but in this video, A is not 1, okay? And it's, I don't want to say it's harder. It's not harder. It's longer. The process just takes a little bit more time, okay? And it's this next video where factor by grouping comes back, okay? So make sure if you haven't mastered factor by grouping, go back and look at it again and make sure you understand this video because concepts from this follow into the next video, but you also have factor by grouping, okay? So make sure you brush up on all of that before you tackle the next video. All right, take care.